So, in this video, we will discuss about solid states. Till now, you must be knowing that there are three phases of a substance. Those are solid, liquid, and gas. These three are the phases of substances, okay, or phase of matters. There are two more other phases. Those are Bose-Einstein and plasma phase, but we need not to discuss those phases here. So here we will remain with only three phases that are solid, liquid, and gas. Okay. Now, air is gas, water is liquid, and a metal rod is solid when at room temperature. So, at room temperature, air is gas, water is liquid, metal rod is solid. So now we have to understand that what are the factors which decides whether a substance will be solid, liquid, or gas at certain conditions. Can you guess those factors? The first factor is intermolecular force of attraction. Intermolecular force of attraction is the force of attraction between the various particles of a given substance or matter. If the force of attraction is high, the substance tends to have to be in solid phase. Okay. So solid have highest intermolecular force of attraction, followed by liquid, followed by gas. Okay. Now, what is the second factor which decides the state of substance? The second factor is thermal energy. Now, what is thermal energy? The definition of thermal energy is similar to the definition of kinetic energy. It is the energy possessed by the virtue of motion. But in chemistry, we take thermal energy in different manners. Suppose if I heat a given substance, then definitely the particles of the substance will start moving and their velocity will increase. So the physics guys said that the kinetic energy has increased. But now see, if there are two particles A and B, A has high speed or velocity while B has low velocity. Tell me which will have the higher amount of thermal energy? Obviously A, because it has high velocity, it must have been heated for a high temperature. So therefore thermal energy is higher in case of those substance which moves very fast. So thermal energy is high for gas, followed by liquid, and it is least in case of solid. Okay. Now, due to these two factors, any substance decides its phase at given set of conditions. Air is gas at room temperature because it has high thermal energy at room temperature, while less intermolecular force of attraction at room temperature. A metal rod is solid at room temperature because it has high intermolecular force of attraction and low thermal energy at given temperature. Okay, note it down fast. And now we will discuss the various types of solids and its classification in. Okay. Now we will learn about the classification of solids. Solids have been classified in two parts: crystalline solid and amorphous solids. Crystalline solids have been further classified in four parts: molecular solid, ionic solid, metallic solid, network or covalent solid. And the molecular solids have been classified in non-polar molecular solid, polar molecular solid, hydrogen bonded molecular solids. Now we will study the properties of crystalline solids. The solids have been first classified on the basis of arrangement of their particles. And in crystalline solid, the first property is that the arrangement of particles is uniform. Means particles are arranged at a regular space and there is a pattern in the arrangement of particles. So first property is uniform or regular arrangement of particles. Okay, now let's come to the second property. Suppose I have to convert this solid into liquid. What we have to do? We have to heat this solid. Let me tell you one thing, there is no such difference in a chemical nature of substance when it is in solid phase or in liquid phase or in gaseous phase. For example, water is in ice form has also the chemical formula of H2O, in liquid form has also the chemical formula of H2O, and even in gas form it has the chemical formula of H2O. But what is the difference between solid, liquid and gas? That the intermolecular space is least in case of solid, it increases in case of liquid and becomes very high in case of gas. So to convert a solid into a liquid, we have to increase this space. Okay, now I am taking a random value. Let the distance between two particles be 10 picometer or 10 units, and if this substance at the distance of 12 picometer converts to liquid, so we have to heat this substance, so the distance increases up to 12 picometer and this substance will convert to liquid. Okay, now everywhere the distance is 10 picometer, same. Okay, everywhere the distance is 10 picometer. Okay, but so everywhere we have to heat, give same amount of heat, so that distance become 12 picometer. And now when the any part where distance become 12 picometer converts to liquid. So therefore in case of crystalline solid, as the arrangement is uniform amount of heat is required at every point. So crystalline solids have sharp melting point. Okay, and a definite characteristic heat of fusion. Okay, because their distance is fixed. Now let's come to the next property. If I cut this solid in two parts, then what will be obtained? These particles are arranged at a uniform distance, so definitely okay. So the surface obtained will be smooth. A smooth surface will be obtained because the particles are arranged in a fixed manner. Okay, so this property is called cleavage property. Means crystalline solids have cleavage property, that is, on being cut by a sharp object they are divided in smooth surface. Smooth surface. Okay, now let's come to the next property. Now the next property is crystalline solids are anisotropic in nature. It is very important property where many students fail to understand. Anisotropic nature means certain physical properties like refractive index, electrical conductivity changes with change in direction of the applied property. Okay. Now let's see. Refraction occurs because of interaction between the light waves and the number of particles in which it travels. So if we change the direction of the light, the number of particles which interacts per unit length changes. Therefore, the value of refractive index changes with the change in direction of light. Therefore, crystalline solids are anisotropic in nature. Let's come to the next point. Next very important point is that they have long range order. Long range order means, see, if the distance between first and second particle is 10 picometer, then definitely the distance between 1001th and 1002th particle will also be 10 picometer. This is because in case of crystalline solid, there is a proper arrangement for a very long range. Okay. That's why we say that crystalline solids have long range order. Now next property is that they are called true solids. True solids because they do not change their position even after a very long time. After thousands of years, they will stick to their respective positions. So they are called true solids. Okay. So note down these points. First, we will take examples when we will further discuss the classification of crystalline solids into its various parts. Okay. Now, for example, we can say that all the metals, their compounds are generally ionic in nature. Next examples we will see when I will reach the classification of crystalline solids. Okay, note it down fast. Now we will discuss the properties of amorphous solids. So, in case of amorphous solid, the arrangement of particle is irregular, not uniform. So here you can see that there is a irregular arrangement of particles. So first is irregular arrangement of particles. See, here at some places the distance between particle is large, while in some places the distance between particle is very less. So, in order to convert it into liquid, we have to heat those portions. We have to give high heat to these particles which are close to each other, whereas the particles which are at large distance to each other require less amount of heat. Therefore, we can say that amorphous solids do not have sharp melting point or definite heat of fusion. Okay? In fact, for amorphous solids, we talk about the range of melting point. Okay, so for amorphous solids, due to irregular arrangement, do not have fixed melting point. Do not have characteristic heat of fusion. Okay. Now, next property. Suppose I cut an amorphous solid with a sharp object, then definitely the surface in which it will be divided will have irregular surface. So we can say that amorphous solids do not show cleavage property. Okay? They do not show cleavage property. That is, on being cut by sharp objects, they are divided in rough surface. Okay? The next property is that amorphous solids are isotropic in nature. Isotropic because some physical properties like refractive index, electrical conductivity does not change with change in direction. Therefore, they are isotropic in nature. This happens because even though they have irregular arrangement, the number of particles per unit length remains same in amorphous solid. Okay, so amorphous solids are isotropic in nature. Next, they have short range order because arrangement is irregular. So if the distance between first and second particle is 10 pm, you can't tell what will be the distance between 50 and 51st particle from there. Okay. So short range order. Next, they are called pseudo solids because they are not there. The arrangement of particle does not remain same after a long time due to effect of gravity. The distance between particle keeps on changing. So amorphous solids have tendency to flow, but very slowly. Okay, so they are called pseudo solids, or sometimes glass, which is also an amorphous solid, is also called super cooled liquid. Okay, the examples of amorphous solids are glass. All the polymers which you see around yourself are examples of amorphous solids. Amorphous solids has not been further classified. Okay, so now note the case properties fast and learn the difference between crystalline solids and amorphous solids. Other questions which you have to prepare is why amorphous solids are isotropic in nature, why crystalline solids are anisotropic in nature. Okay. Now I will discuss the special case of glass. Glass is prepared by quartz. Quartz is crystalline in nature, but when it becomes glass, it is amorphous in nature. It means it is possible for us to convert a crystalline substance into an amorphous substance. Okay, so what we have to do is melt the quartz and followed by sudden cooling. See, what happened here is, in case of quartz, the arrangement of particle is uniform. But once it is melted, the arrangement of particle becomes irregular because in case of liquid, the particles have tendency to flow. So the particles of quartz also starts flowing. But upon sudden cooling, all these particles are stuck at their place, and thus the arrangement becomes irregular. And even if it solidifies, the arrangement does not changes and remains in amorphous glass. So this problem of sudden cooling is called quenching. So from this discussion we have understood that a crystalline quartz can be converted into amorphous. Okay, but how we can convert an amorphous substance into crystalline substance? That is also possible. Just again melt followed by slow cooling. Because in case of slow cooling, there is sufficient time for the particles to arrange themselves in a proper manner, in which so that they can attain a good crystalline arrangement. Okay, hence And the process of slow cooling is called annealing. Note down this case of glass, which is very important. Now, in case of old buildings, you must have seen that the window panes become thick at the bottom edge while it is thin at the upper edge. This is because glass is an amorphous solid and it flows downwards due to effect of gravity. Therefore, glass is also called supercooled liquid. So note down this properties fast. And in next video, I will discuss about the classification of crystalline solids and various examples of the crystalline solids. Okay?